In today's tutorial we are going to discuss the reaction of 1,5-dibromopentane with ammonia in methanolic solution in the presence of potassium carbonate. So, first step of course is to figure out where are the reactive centers. This is pretty easy in this case. We have alkyl bromides with positively polarized carbons, and the best nucleophile in the reaction mixture is of course the ammonia with its free electron pair. The reaction mechanism for the first step is the nucleophilic substitution according to an SN2 process. Because primary carbocations are generally unknown or almost unknown, since they are not very stabilized. Starting with secondary carbocations, they are pretty common. So, nucleophilic substitution will form this ammonium salt in the first step. And if you perform this reaction in an apolar solution, for instance in toluene, then this salt will fall out of the solution as a white powder, a colorless powder. But here we have methanol as a solvent. Methanol is capable to solubilize such an ammonium salt and also the potassium carbonate as a base, and therefore the base is able to deprotonate. So minus HBr, and we will have then a primary amine and intramolecularly offered an alkyl halide. Again, nucleophilic substitution will lead us then to a cyclic product, again an ammonium salt. Another deprotonation step will set free the base, the free nitrogen base, called piperidine. Piperidine itself is also nucleophilic, and if you want to avoid that the piperidine will react as a side reaction or following reaction with the starting material, you should avoid that it is formed too early. You can achieve that if you apply only 1/2 equivalent of potassium carbonate in this first reaction step, and secondly add another 1/2 equivalent of potassium carbonate when you are sure that all the starting material has been already consumed. So, this is a possibility, a way to synthesize piperidine. However, every synthesis that applies alkyl halides like that, especially alkyl bromides or alkyl iodides, is rather expensive. There is a much cheaper way to synthesize piperidine, and generally this is done starting from the aromatic pyridine, just by reduction, for instance, with molecular hydrogen under high pressure and Rennet nickel as catalyst. This is the appropriate way to synthesize piperidine on a large scale. Thanks for listening.